Hello. A while back I did a video describing how to calibrate a 141T spectrum analyzer display section. And in that video I explained that even if your display section has a damaged CRT, you can still get it to work by hooking up the plotter outputs to an oscilloscope. What I have here is a parts unit of mine that when I originally got it, it had a cracked CRT. I've since removed the CRT, but now it has no display section. But everything else in it pretty much works as far as I can tell. And what I'm going to do is I'm going to explain to you how to set one of these up to display to an external monitor like an oscilloscope or an XYZ display. Now, in order to make sure that we can safely hook this display section up to an oscilloscope, is we need to do two things first. We need to, one, check that the low voltage power supply section is working properly. This is just to ensure that we don't damage the plugins when we turn the unit on. I pretty much explain how to do this in my calibration video. The procedure is basically the same, but the other thing we need to do is we need to disable the high voltage oscillator. Because the CRT is removed, or perhaps in your case it might be cracked but still in the mainframe, we're going to need to turn off the high voltage oscillator because the storage grid runs, at such a high voltage that even through a cracked CRT, you can still get electrical arcing across the storage grid, and that's just not really safe. So we want to disable it first before we try doing, this with a damaged display section. So what we're going to need to do is we're going to need to turn the unit upside down and open up the high voltage section. So now we have the unit turned over and the bottom cover removed and also the high voltage cover removed. And the first thing we're going to want to do is turn off the high voltage oscillator. The two components specifically that we're going to want to remove are L1 and R57. So if we look at the schematic for the high voltage section, if we look over here to the high voltage oscillator that's run from Q13 right here, the negative 12.6 volts that it runs off of is connected through L1 right here, and the ground is connected through R57 right here. And if we look at the board layout in the manual, we will find that L1 is up here right next to this large capacitor, and that R57 is over here next to a bunch of other components. So if we look down on the board inside of mine, I've actually already performed the modifications necessary for this. So if I take the camera out and show you, you can see that is where L1 would have gone, and over there, right in this spot right here, is where R57 would have gone. And so I've just unsoldered both of them, and I've put those away in just a bag that I have taped to the bottom of the high voltage panel here. And so don't lose those. They're pretty important, and if we ever do find a way to replace the CRT in this, we're going to want to put those back. But we'll talk about that at a later point. But for now, we can be relatively certain that the high voltage oscillator is disabled. I think removing either one of those components would be sufficient by themselves, but by removing both, we can be doubly sure that the high voltage is in fact off. Now, with the high voltage oscillator disabled, the last thing we're going to want to do is check that the 4 low voltage power supply rails are working correctly, so that we can put in the plugins and be sure they won't damage them. And again, this is exactly as I just explained in my previous tutorial on calibrating it. we're just going to turn the unit on and just check each of the 4 rails. And so we're going to get out our multimeter here, and we are going to put one probe against the case ground, like this, and we will check each of the power supply rails in turn. So the plus 100 volt rail is against these red and white wires here, and I'm reading 100 volts on the dot. I did actually calibrate it before this video, so it's probably going to be pretty much right on. It's then the negative 100 volts here. That's measuring negative 100.1 volts. Then the positive 248 volt supply, I'm reading positive 248.2. And lastly, the negative 12.6 volt supply, which is reading negative 12.57. So that all seems pretty good. And so now we can be relatively certain that when we put the plugins in, it's going to turn on safely and work properly. And as a final note, just to be, triply sure that the high voltage oscillator is in fact disabled, I've brought out my high voltage probe here. And as I showed in my calibration video, I'm just going to connect it up to the case ground here, measure it off of the green wire here, and I am getting effectively 0 volts. So that is the high voltage power supply well and truly disabled. So now we can close up the case and put in the plugins and begin actually hooking it up to the oscilloscope. So now we have our spectrum analyzer all closed up and put back together again, and also I have put in some spectrum analyzer plugins in. I've used an 8555 18 gigahertz RF section. And up on top of it here I have my Hitachi V1100 oscilloscope. And what you're going to want for this is an oscilloscope that has an XY mode, a Z-axis or blanking input. This one has it on the back. Most analog oscilloscopes will have an external Z input. Not all digital oscilloscopes do. I also have a Tektronix TDS-340, which, although it has an XY mode and all the other requirements, it doesn't have an external Z input on the back. So I had a lot of trouble getting it to work with the external trigger. It was just a very messy looking trace. But analog oscilloscopes like this take an external blanking, so it blanks out the trace while it's retracing. So that's important, and you're going to want that. And the last thing that you're going to want is preferably the option to invert channel 2, because the vertical output from the IF plugin is actually inverted. Unfortunately, my oscilloscope doesn't have the option to invert channel 2, so the trace is actually going to be upside down, but otherwise it's going to be completely the same. And so what we're going to focus on here are the 3 plotter outputs on the IF section. So first is going to be your scan in and out. That's just going to be your horizontal sweep from the spectrum analyzer, and we're going to plug that into your x-axis, which is channel 1 on my oscilloscope. The next is the vertical output. Like I said, this is inverted, so you're going to want to invert that channel if you have the option to on your oscilloscope. And I'm going to plug that into channel 2 or the Y channel on mine. And the last is the pen lift output. So obviously that refers to a literal mechanical plotter that would have had a pen that lifted up or down. But in this case we're actually using it as a blanking signal. So we're going to plug that into the Z-axis input on the back of the oscilloscope. So I'll come back in a moment when I have that. Alright, so now that we have our plotter outputs hooked up to our oscilloscope with just regular BNC cables, we can actually begin turning the unit on and doing some testing. So in order to do this, you're going to want to have your oscilloscope in XY mode. You're also going to want to have both channels to DC coupled, and also you are going to want to set your volts per divisions on your two channels, your vertical scale, so that the trace fits onto the screen. So I'm just going to increase the intensity here. Well, that's interesting. So, those of you who watched my calibration video may remember me making an offhand remark about the plugins sometimes blowing their fuses when you turn the unit on. Well, it turns out that the unit just did that now. And so, I'm just going to show you what happened. Basically, the lights on the IF plugin were working, but it wasn't scanning. So what I'm just going to do now is I'm just going to replace the fuses on the back. I don't know if you can see there, but the filaments inside the fuses are in fact blown. So I'm just going to get two ordinary 1 amp fuses, and I'm going to replace the fuses on the back and plug them back in. So I believe normally you should use slow-blowing time delay fuses, but all I have are fast-blow fuses. That's possibly part of the reason why they keep blowing, but I'm just going to keep going and just replace them with these for now. And so I'll get back to you once I have these plugins back in the unit, and we'll leave off where we just were. So now, with the fuses replaced in our plugins and the plugins back in the unit, we have the unit hooked up, and you're going to want to have your x-axis, you're going to want to have the vertical scaling of channel 1 set to 10 volts per division, and your Y channel, or channel 2, set to 1 volt per division. And this will pretty closely match the horizontal and vertical scaling of the 141T's display. And so, and if you want to more finely adjust that, you can use the verniers on your oscilloscope if you know how to use those and want to. And you'll see now that actually the trace on the screen, let me just adjust the vertical position here, and also turn down the brightness on the readout so all we can see is the trace. You'll see that this in fact responds to all the same controls as you would normally find on as if you were just operating it normally. And so what I'm going to do now is I'm going to hook up the calibration signal from our IF unit to the input here, and we can see how accurate this display is. So if we just adjust the channel position here, and then if we turn the logarithmic reference level up and down, you can see that the vertical scale is moving by 10 dB, or 1 division, every time we turn the logarithmic reference level. So you could actually use this for measurements. So if we have it set to 10 megahertz per division, it's a 30 megahertz calibration signal, and we adjust the center frequency, you can see that in fact these are 3 divisions apart. So it is accurate on both the vertical and horizontal scale. So this could be used to take measurements using these spectrum analyzers as sort of a stopgap solution. But I'm also going to talk about some of the things that you can do moving forward if you do have a 141T with a damaged CRT, and how you can, find a better solution than having to do this every time you want to use it. So, now that we've demonstrated that you can as a temporary solution, hook up the plotter outputs to an oscilloscope to use as a display output, you can begin talking about perhaps some slightly more permanent solutions to getting a 141T working again. The obvious first solution would be to just buy an empty display mainframe. They do exist on eBay, just mainframes with no plugins in them, and they're usually not overly expensive, although you run the risk that because they don't have plugins in them, they're probably untested as well. So you run the risk of getting another dud display section. But as long as the CRT isn't cracked, they're usually fixable. As I explained in my repair video, you know, there are no real exotic components in the 141T, just sort of regular transistors, resistors, and capacitors. So they are very repairable. Another solution that I've seen used many times is to actually take a 140A oscilloscope mainframe, pull out the oscilloscope plugins, take out the center divider, and put in the spectrum analyzer sections and use an oscilloscope mainframe as a spectrum analyzer. These oscilloscopes, the 140A and also the storage version, the 141A, are very old. They date back to the early 1960s. The oscilloscopes themselves aren't terribly impressive by modern standards, but they were modular, which is very interesting for the time. And that can work. They are actually, the 141T is backwards compatible with the 140A. It uses all the same power supply voltages, everything. The one issue with that is that you won't be able to use any of the add-on boxes for the 141T, such as the tracking generators or the pre-selectors, because it doesn't have that D-sub connector on the back. Another issue is that unless you have a 140A that already works, you're going to need to repair that too. And that's actually quite a bit harder than on the 141T, because these date to a time back when, you know, it was not completely solid state. Many of the high power parts of this, the power supply and the display section, still run on vacuum tubes, and also in a few places they're still using germanium transistors. So sourcing parts for these can be pretty tricky if you have to fix one up. That said, it is a viable solution, and these work actually really well. You'll see plenty of listings on eBay for you know, spectrum analyzers that have been retrofitted into these old oscilloscope mainframes like this. Another thing I've seen done is if you know, they want to keep using the same 141T mainframe, but do sort of a more permanent version of the oscilloscope trick I described earlier, I've seen people who have hooked up LCD displays inside the oscilloscope with an oscilloscope just plugged into the plotter outputs on the IF unit. So you could almost use something like, you know, something like this, these little VGA displays that are normally used for like Raspberry Pis and things like that, and you could install it into the 141T as a replacement screen. I've always wondered if there would be a way to do a slightly more advanced version of that might have, you know, an on-screen display or something like that, you know, maybe programmed with either like a Raspberry Pi or a microcontroller of some kind. But unfortunately, I'm really not very much of a programmer, and I have a lot of other projects that I'm working on. And the last option, and possibly both the simplest and perhaps the hardest to come across, is to find a replacement CRT. And you would normally think that it would be impossible to find replacement CRTs for a 40-year-old spectrum analyzer. But believe it or not, new CRTs or old CRTs from 141Ts do crop up on eBay from time to time. I have, right here on the right, a new in-box CRT for a 141T. And at some point I actually plan on fixing up that old parts unit with this new CRT. So you have a lot of options. Just because, you know, the display section doesn't work, as long as your plugins work, you have options. And you know, even if the plugins didn't work, they can be repaired too. It's all just a matter of, you know, taking the time to sit down and really just, you know, just go through it one problem at a time and get everything working. Just as a final note before this goes on too long, I just want to say I hope this explanation of everything was helpful, and that, you know, everything I said could help you get one of these units working again. And if you have any questions, please feel free to leave a comment below, and thank you for watching.